Okay, so we are now on page 478. We're going to do example number 7. Example number 7. We have Gary walks along a horizontal line. Think of it as a number line with the coordinate of his position in meters given by that, where t is between 0 and 12. Use parametric conventions on a grapher to simulate this. So let's go ahead and simulate this. So on your graphing calculator, let's go ahead and so on x1, let's put negative 0.01 t cubed minus 20 plus 110 or minus 20 110 minus 85. And on for your y1, let's go and just put 5 and go ahead and graph that. See what it looks like. Is it a line? Or did you actually see the motion?
I got a go to or quit.
It went this way.
And so it went this way and then it went, oh, did it or not?
I think my window is too small.
Let's look.
Yeah, why did it tell me to quit?
No, it just went that way.
Yeah.
Okay.
Am I in the wrong
So-
line again?
The problem is this. The problem is what's happening is that you said y is equal to 5, right? So y is equal to 5, and it's going to go from here. It's going to go this way and that way, I think. Is that it? Yeah, it goes this way, and back, maybe, or something like that. But you can't tell. It's hard to tell, right? So let's go ahead, instead of 5, let's put this guy in and see what happens.
Oh, it says I should quit. And well, you put in a minus sign, didn't you?
Oh, then it goes.
No. It went.
So now you can see that it goes like this and this and this, right? So you know that it went from here to here and back to here.
What's a window?
What's
What's the window?
No, but like
Whatever you want it to be, so you can see the motion.
We only saw the first half.
it doesn't.
It only went like this and it kept
But
going.
change the thing.
Yeah, so your window is too small or too big.
What's your guys' window? Yeah.
Never
I think
changed
it's 33.
Is your window too small or too big?
I'm trying to. Okay.
Too big. If it's too big, you wouldn't be able to see it because it's so small.
Oh,
Is your window too big or too small?
too small.
Oh, so then you should widen your window.
What about length?
Did everybody get this?
No. It stopped. It doesn't go.
Yeah, because your window is right here right now. I think your window is like
I
here.
just
And
Oh, mine does that, but it stops.
Stop.
stops at t equals what? Where's your t max? What is your t supposed to be?
6.2.
Huh?
6.28.
Your t according is supposed to be from 0 to 12, is it not?
Huh?
Changed it.
Read the question, example number 7.
I changed it.
Let me see your one.
I did it.
It's
Isn't
t
it
is supposed to be
says
0
0
to 12.
I fixed it. Now it does that.
Now it does that? Okay, so actually what happened then is that from here, you went from here to here, back to here, and then back to here. So by putting the negative t in here, all it does is it's showing you the actual motion that's happening here, right? Here, here, and here. Does that make sense? So it's basically like shining a light from this side, and you're seeing the reflection of this guy onto this line. That's just showing you little tricks of how you can actually make it so that you know. So basically the distance traveled here is going to be this plus this plus this, right?
Yes.
Okay. If I ask you for the displacement, the displacement from would be from here to here,
Why?
because the displacement is S2 minus S1. Right, whatever this position was minus whatever this position is, right? It doesn't count that you had to go back and forth.
Oh, okay.
Right, so difference between displacement and distance travel. Okay. Let's go to example number 8. Example number 8: a distress flare is launched from a ship's deck 75 feet above the water, with an initial vertical velocity of 76 feet per second. Graph the time and So I have, this is the ocean, I have a boat,
That's a good
and
one.
I'm gonna go from here, launch it, it's gonna come down like this.
Wouldn't it be more horizontal? If the wind would push it more?
There's no air resistance.
I don't see any wind.
We're at the ocean.
Where's the wind?
We're at the ocean.
How is that a boat?
So,
It's windy at the ocean.
there's your sail.
Now there's wind. 'cause it's
Yeah, so
still
then there's
up.
definitely wind. 'Cause it's still low. What?
So, this height here is 75 feet. Okay. So those of you who have taken physics, your S is gonna be equal to what? 1/2 AT squared plus V naught T plus S
Oh.
naught.
That looks familiar. We didn't have to see the paper. We don't have it memorized.
I think the variables are different too.
Yeah,
Okay, so A being what? A is what?
acceleration,
What kind of acceleration?
gravity.
Gravity acceleration. So it's gonna be negative, and we're talking about feet here, so it's British unit.
Oh, so 32.6.
So it's gonna be negative 16 T squared, right? Because it's negative 32. A is negative 32.
Yeah.
So it's negative 16 squared plus initial velocity was what?
Probably 76 feet per second.
76 feet per second, and my S naught original height was 75 feet above. So it's 75.
Is there a reason why you made you 16? Did you already get rid of the 1/2?
Okay, so I just explained this while you were yakking away over there.
I'm a bit confused.
Yeah, so it was 32.
Yeah, but then you divide it.
Oh,
Is it a
that's-
decimal one?
Come again?
Is there a decimal or do we just round
A
down?
decimal on what?
Force of gravity.
Yeah. Per
Not
feet.
force of gravity, acceleration of gravity. Speed of gravity.
You,
whatever.
you learned this as not 32? Where did you learn that?
In British,
We
it's
never,
never
we only
32.2.
use meters per, we did 9.8.
Oh, so that would have been 9.81 meters per
Yeah.
second. Is this what you're talking about?
But as
Different
feet,
unit.
it's
Yeah, but then when you
32.2.
put it in the feet, when it's still, it wouldn't be even.
So you want me to use this divided by 2?
No.
Because that would be meters, and this would be feet. Because this
Yeah,
is
but-
feet per second.
Isn't it
You're just
32?
converting meters to feet wouldn't be
Yeah, right, when it's,
What?
would there be a decimal?
What is the conversion from meter to feet?
32.2.
What?
Okay.
So 1 meter is 32.2 feet?
No, that's
no,
what I'm saying.
total.
I'm saying that the conversion from 9.81 meters per second squared to feet per second squared should be negative 32.2.
Oh, it's 32.2.
Shouldn't be, it couldn't be a whole number, but if it was converted.
Oh, yeah, 32 point. So then it'd be.
That's what we're
16.1.
talking about.
Okay, so look at your book.
They use
What does your
32
book
be. Well,
say?
you say the book's wrong.
Yeah, that's true.
What does the book say?
It's, I don't know.
Read it.
I
I
can't see
should
that.
stop.
Vertical velocity is 76.
76.
Uh-huh.
It says negative
But we're talking about gravity.
16.1.
Negative 16.
.1.
Negative 16.
Yawn.
So- So this is the equation that gives you the height at t seconds after you launch this thing. Okay? Right? So the question is, when t is equal to 1, equal to 2, equal to 4, equal to 5, you can go ahead and plot it. Okay? We're not gonna do that. Let's go to example number 9.
Oh,
Hitting a baseball.
Just hit it. You don't even have to read.
Okay, so
Yeah, you probably should.
this type of equation, what we call the parabolic or velocity equation, again, will be on the test. Let you know it'll be on the test. I will give you the equation though, so you don't have to memorize the equation.
Let's a go.
What's a go?
Let's a go. I'm celebrating.
All right, okay. Example number 9. Example number 9, we're hitting a baseball with Kevin hits baseball at 3 feet above the ground. initial speed of 150 feet per second at a launch angle of 18 degrees at the horizontal. With the ball, will the ball clear a 20-foot wall that is 400 feet away?
Oh, I remember.
So we have, we're gonna hit it 3 feet above, and there's a wall here at 400 feet that is 20 feet high. We don't know if it's gonna clear the wall or not, right? That's what we're trying to find. So the distance traveled this way, okay, in the x direction, because the velocity is like this. The velocity has actually two components, right? The x component and the y component. This is 18 degrees, and it was 150 feet per second. So this is going to be the cosine of that. Cosine 18 degrees. This is going to be sine 150, sine 15 degrees. So in the y direction, we're still going to use that same equation we just used. Negative 16t squared, not 16.1, 16. Plus the initial velocity in the y direction, t, plus the initial height was 3 feet, because it was 3 feet above. So this is in the y direction. Okay. In the, so let's call this y. In the x direction, what's happening in the x direction?
Cosine.
It's cosine, right? So 115 cosine 18 degrees. What force is acting against in the x direction?
Nothing.
Nothing, right? Nothing's,
Wind.
I mean,
Wind. Yeah, what about
air
wind?
resistance, if you want to call it, right? Air
Are we in a
resistance.
vacuum right
So if
now?
we call that negligible, every second you're going to go this much to the x direction, right?
Yeah.
So this is going to be your formula, right? So this is going to be 20, right? The wall is going to be 20. So we need to find out at what point does this 20 happen? What, and when t is equal to what? Right? And we have to find out, because we need to find out whether or not it will travel the 400 feet. Because that's the question, right? So you would go ahead and put that equal to, okay, the book says just go ahead and graph it. So you just graph it.
So we do the equal.
So if you graph this and this, okay, you should be able to find out whether it clears or not. Not clearly, it does not clear the wall. Okay. So yeah, so it's doesn't look like it's even going to be a ground rule double. It looks like it'll get caught on at the warning track. Okay, example number 10. Example number 10. We have a Ferris wheel. Riding on a Ferris wheel. JD's riding on a Ferris wheel with a radius of 30 feet. The wheel is turning counterclockwise at the rate of 1 revolution every 30 seconds. Okay, 1 revolution every 30 seconds. Assume that the lowest point is 10 feet above the ground. Okay, so it's a radius of 30. And it's 10 feet above the ground. The radius is 30. So what is this point here?
10. Oh.
This is 10.
40.
40, right? So this is going to be 0, 40, correct? Because x is 0, y is 40, right? Okay. So your equation is going to be y is equal to, and it's a 30 degrees radius, 30 feet radius, sine something here plus 40. Does that make sense? Right? Where did that 40 come from?
The height.
That right here, right? Because if without this, it would be at the origin and 30 around, right? But I had to raise that up in the y direction. That's why I'm adding the 40 here, right? So all we need to do is figure out what's in between here, right?
The angle.
And what is going to tell me that?
The point.
No.
It was-
I need to find the period or the frequency, right?
Yeah.
Remember this guy is going to be 30 seconds, correct? Because that's how long it takes to go travel around one cycle, right? Right? So B is going to be equal to what?
2 pi over 30.
Does that make sense? Are we good? Okay, so we put that, and so that would be the y. The x is going to be what?
We have no f.
30 cosine.
Because it'll be the cosine, right? Because the x starts from here at 30, right? This is 30. The x component is 30, goes to 0, negative 30, 0, positive 30. So it's a cosine, right? So this is your parametrization right here. And blah, 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 find the parametric equation. So let's go ahead and graph that to make sure that you actually do, this gives you this guy. Let's go ahead and graph that. This you want to be in radians, obviously, right?
Pretty hungry.
So now you're gonna have to change your windows. What would your windows be, Ezekiel? In the x direction.
Oh, the x direction? 40, right?
40? So I want to be able to, I want to see this in my window, right?
Yeah, you want like 50.
So a negative 62, like a negative 50 to a positive 50. And here would be from, I don't know, negative 10 to 50.
50. You know, I see.
Oh, no, negative 10 to 80.
Yeah.
Oh, not at least 80, so 90. Let's do 100.
For one. Oh, my. See what happens.
Oh, okay. Under there. In there. Wait, what's your window? Yeah, what's a T-minute max, Mr. Rob?